Okay, so before this session, we are now familiar with regression problems and classification problems. Like we discussed that in the regression problem, we deal with the continuous dependent variable, or our target variable is a continuous variable, and in classification, we try to deal with the categories and we predict different categories, right? Now, before that, we learn linear regression model that only deal with regression problems, and we learn a logistic regression model that deals only with classification problem, right? Now in this session we are going to talk about a model that can deal both kind of problems. Like we have a model that can deal with the regression problem and it can also deal with the classification problem. The model we are going to talk about is decision trees. Now, decision trees is basically a supervised machine learning algorithm. When we say it's supervised machine learning algorithm, it means that we know what we are trying to predict here. We have a clear-cut dependent variables, and we know that we want to see relationship between these independent variables with this particular dependent variable, right? No, as name suggests, it's a decision tree. So basically, we form a kind of tree here that have a root node, internal nodes, leaf nodes. So basically, it's a tree-like structure that classify the data into different problems. Now, if you want to see that, how does it look like? It looks something like this, something like this. Now, if we want to see that what actually is going on, we will discuss it in the series, in this lecture. What we are basically trying to do here is we are trying to do a classification problem, and we have some independent variables. Based on that independent variables, we form a tree like this, and this tree will help us to predict our dependent variable. Like in this particular examples, we are now alcohol is an independent variable, sulfates is an independent variables, and we are doing classification based on that. If alcohol is less than 10.35, then the rows with this particular condition goes into this block, and with no condition like this go to this block. So we will go into that in a few minutes. Okay, now we have all the training data, right? Again, it's going to be the same process. We will start with training data and testing data. So basically we have complete data, we split it into training and testing sets. Now training set is going to help us to build that tree. Okay, once we have the tree, then we can get prediction for any kind of data based on that tree. Now, for example, in this particular case, we are talking about wine quality data. Now, our data set is related to wines, and we have different terms related to wine, like fixed acidity, critic acidity, residual sugar, colorides, and all that. And we have data for different wines, and for each wine, we have a quality score, like 5, 4, 6. Okay. Now, here is the thing. Now, this is kind of problem where we can use regression and we can use a classification. Now, how we can do that? Let me explain. Again, we are doing the same thing. We are starting off with loading our data set. We are seeing is there any kind of missing values. We are seeing descriptive statistics, or that we say df.describe function. Now in df.describe, we can see that the minimum quality score is 3. Okay, and the maximum quality score that we are getting is 8. Now this is a continuous number. Like we can say that 3, we can also say that quality score of 3.5, 3.2, 3.1, right? Because 3.2 is basically better score than 3, right? So it is kind of regression problem, but if we want to make a classification problem from this, we can also do that. How we can do that? For example, if we say that 3 quality score of 3 and 4 is going to be very low, and we will say it's low quality. 5 and 6 is going to be medium quality, and 7 and 8 is going to be better quality or good quality. So we can basically create the classes based on that, and we can deal with it in a classification term. Rest of the code is going to be the same. We are checking the value counts. We are creating different kind of graphs here to see the distribution. Like we have quality score of 5 for 42% of the data set. Now to convert it into a classification problem, we will modify it to 3 classes with a simple function that if quality is less than or equal to 5, it's low. If quality is equal to 6, it's medium. If it's greater than that, it means it's going to be a high quality wine. Okay. Again, we just defined a function, and once we define a function, we can use it with the same name. Like here, we are using categorize quality, and y is basically our data set, the dependent variable from the data set, right? And apply function, apply this particular function on the data. Now, why we are doing that? We are basically trying to create a classification problem. Again, some visualizations that we do with matplotlib, figure size, plot, kind. We already discussed all that stuff, so I'm not going in depth with this, but still, that's a correlation plot that we discussed. We can see that. Again, code is going to be 100% same. All we are just, if we are going to differentiate something, it might be the name of the data, or labels, and something like that. Rest of the things are going to be exactly the same. So now here in decision tree, we use decision tree regressor. Okay. Now, if we are dealing it as a regression problem, it's going to be the regressor. And if we are dealing it with the classification problem, it's going to be decision tree classifier. Now, when we are talking about the regressor, we are going to take the data as it is. Like we are going to take it as a number from 3 to 8 that they already have. Okay. And if we are trying to use classifier, so we will basically go with the data transformation that we did like this. So basically we create 3 categories, we make 3 classes, and based on that we will do classification. Again, same split style that we split data into training and testing. We import the decision tree classifier from sklearn. Now here we have max depth. Okay. Now the problem with the decision tree is in decision tree we have to tell about the depth. Okay. Now it doesn't make any sense that we have a clean data set, or every time we are dealing with some kind of problem, we will be able to form a tree like structure that helps us to separate our classes, right? It's not 100% possible. Sometimes we have a data set that is so much complex or so much messy that we cannot even separate them based on the conditions, right? So that's why we have to tell the Python that this should not make 2 or 3 or 4 more than 4 splits. Now this is a one split, this is the second split, and this is the third split. Now we know that data set is complex and it is not going to be 100% separated. Like we have in this particular case, we have 3 conditions, like high and medium and low, right? So we need at each end we need 3 blocks where we have highest number of different categories separated in each. Okay. And now, before jumping into that, this is our root node. The top node is basically the block, basically we call it node, and the first one is called root node. So whenever we're talking about the root node, basically we're talking about the whole data set, that from that's this point we're going to start. All the nodes between are going to be the internal nodes, and the nodes and the end are going to be the leaf nodes, right? We start with the whole data at the root node, and we do split based on conditions, and after doing that we make a decision that this is the most important layer, that at this particular point we are able to separate our categories. Okay. Not 100%, 80%, 90%, or as much as possible. So now here is the question, that how does it know about the conditions? Like if you're talking about it's splitting alcohol, it's doing first split based on this particular independent variable and second based on some other independent variable. How does it basically decides? Now, the important thing is we have this particular data set, this, right? And we are trying to make a tree-like structure that helps us to identify the quality. If someone come to us with all these matrices for any wine that we haven't seen before, we don't know about its quality or anything, we say, okay, we made a tree that can help us to identify that how its quality is going to be. So based on that tree, we take the data and we just go through the tree. Okay, the first condition was alcohol should be less than this. is it or not? If not, then we will move on to the next node, check the next condition, and at the end of the day, we will get with a proper classification that this is going to be a high quality wine or a low quality wine. Okay, now move on to the second question. The main thing that, I mean, coding is not that important. We know that most of the syntax right now, because we already worked with sklearn, we already worked with all kind of matrices. We already know what a classification matrix is, what a confusion matrix is. So let's talk about some theory that how does basically decision tree works. Now I created a PDF and I will share it with you. Okay, so decision tree basically worked with two different formulas. It either works with Gini impurity and the second formula that it's going to be based on entropy. Now, for this particular example, we are going to work on this data set. And with this data set, we're basically trying to do everything manually so we can understand how does it's making all kind of decision. This is basically the formula and how it basically works. What is PFI? We're going to discuss all that. So no, in first method, this is the formula that's going to help us. Here, S is basically our data set, the set of sample that we're talking, and PFI is basically the probability. Now, to understand this formula, we are going to use this data set. And now there are two formulas. This is for impurity, our Gini index, and the second one is going to be the entropy. So basically, we have to calculate this first, and then we will use information gain formula that will help us to identify that what variable is the most important and what variable should be used at the first node. Now, this is our data set. We're trying to predict either they should play tennis or not based on the weather condition. Like either it's a sunny day, it's a hot, it's what's the humidity level, how is the wind, is it strong or weak? So based on that, we're going to predict either they should play tennis or not. Now, till now, we are at this point. We want a variable that is the most important variable in the data to split. Okay. And the end goal is to have nodes with clear that either they should play or not. Now, if we take a look at that, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, almost 10, 9 yes, and remaining a no, right? Total, there are 14 samples. We have 9 yes samples and 5 no samples, right? Now, if we take a look at this formula, what we need here is we need probability. P is basically probability. I basically means probability of class. In that particular case, we have two classes, yes and no. So we will go with both of them. Like for example, probability of yes is 9 by 14. So basically there are total 14 samples and out of 14, 9 are yes and 5 are no. So that's why we are getting P of yes is equal to 9 by 14. P of no is equal to 5 by 14. Got it? Now what we need to do is we just need to use this formula 1 minus summation. Summation basically means sum of these probabilities. 1 minus sum of these two probabilities, and we also need to take the square here because we have a square in the formula, right? We will get a number for Gini and it's going to be 0.46 in this particular example. Okay. Now if if we have a Gini is equal to 0, it basically means our data set is pure or we only have one kind of sample, right? So when Gini can be 0, basically when we have all this term is equal to 1, and when this can be 1, this can only be 1 when we have only single class. If we have all the sample of yes, it's going to be 14 by 14 and we will get 1 here as well, right? And it's 1 minus 1 is going to be 0. Okay, so how much the number is larger means how much impurity our data set have. Now this is the Gini of complete data set. After doing that, what we're basically trying to do here is we are trying to decide what variable should go first. Okay. Now, we have the Gini of the complete data set. Now we will check for the independent variables. Now these are independent variables: outlook, temperature, humidity, wind. We will check Gini of each of them, and based on that, we will make a decision. Okay, now in Sunny, we have 5 samples, two are yes and three are no. So if we go here in outlook column, we have classes like sunny, overcast, rain, and all that. Okay. And if we are talking about the sunny category only, we have two no's here and three no, one yes, and three no's, two yes, like this. Okay. Two yes and three no's. So basically, we will start with single independent variable. We will take the Gini of all the categories here. Like for example, for sunny, it's going to be this. For overcast, it's going to be this. For rain, it's going to be this. And once we have for Gini for all the categories in the first independent variable, then we will just calculate the information gain. Information gain is basically the second formula that's important in this. So this was the Gini that we are talking till now, and this is the information gain formula. So, and how it's going to be work, I will show you. And now first we take the Gini of complete data set or the root, this one. So this is going to be at the start 0 point and minus we will talk about the weighted average of Gini. Children basically mean the subcategories. Okay. And here we're talking about 5 by 14 because the first category in that particular case, Sunny, appears 5 times in the data set. Okay. And there are total 14 rows. That's why this, the Gini for Sunny in Outlook is basically representing 5 by 14, right? So that's why we're getting 5 by 14 multiplied by its Gini index. For overcast, we have 4 samples, so it's going to be 4 divided by 14 and its Gini index, that's going to be 0. And in the same manner, we will get it for rain. At the end, we get a number 0.118 that basically represents the importance of this whole column. Okay. And after that, we will repeat the same process for all these columns, the independent column. And based on that, we will make a decision which one is important. Okay. And the second formula, or second technique that we can use in decision tree model is based on entropy. Okay. Now, what we do in entropy again, it's the same thing, but with different formula. Again, it's going to be a formula for entropy and information gain. In the same manner, we have formula for Gini index and then for Gini gain or information gain, as you can see. Okay. No, the difference is just going to be a minor. Instead of using simple calculations like 1 minus summation of probability square, we are just going with some logs here. Okay. PFI multiplied by log 2, again PFI. PFI again represent probability of categories. And if we're talking, so basically it's kind of same thing. We will just use it as it is, like we will calculate the probabilities, and here we use Gini index formula. Instead of that, we will use entropy function if we are going to go with the entropy information gain. Okay, now if we take a look at the code in decision tree classifier, so basically we need to provide that either we are going with Gini index or we are going with entropy function. Okay, so basically these are two different methods that decision tree uses for generating predictions. So it's totally up to us. Either we can go with entropy or Gini index. Based on the data, sometime Gini will be better, sometime entropy will be better. So it's totally up to us. So now here we did the calculations with entropy formula. So what we basically did is again the same example, but now we are using entropy formula, and here we are going with 9 by 14, basically 9 yes out of 14 log 2 of 9 by 14 plus. So this is basically representation of the formula. Now if we look back at the formula, minus summation of probability multiplied by its log value. Okay. And this is exactly what we are doing. Minus probability of occurrence, like if it's yes, 9 by 14, if it's no, 5 by 14, multiplied by log of its value, log 2 of its value. Okay. So again, this is going to be the same process. We calculate for the whole data set, then we calculate for each category in every independent variable. Based on that, we will make a decision that Here, Outlook have a information gain of 0.246, temperature has information gain of 0.029, and humidity have information gain of 0.1. So whatever gives us the highest value, we will go with that, right? In this case, if information gain is giving us the highest value, we go with the information gain here, and we make a decision that if we will make a condition that if in information gain we have these categories, and based on that we will split it into further categories. Now we did that to decide the first column. Then once we have this column, we will again do the same process, and we will calculate entropy or Gini index, and then information gain, and then decide what column should go next. So that's basically how decision tree works. Now, if we are talking about the regression kind of problem, like if we are dealing with a column that does not have categories and that has numbers. Okay, for example, in this particular case, we have credit score, and we have to predict yes or no in the loan approved. Okay, and we are trying to decide that how we will make the splits, because we have a continuous, we got numbers here. So now in continuous, we have so many categories, like we can split on 590, 600, 610, 620. So it's totally a lot of numbers that we have to calculate if we started calculating it manually. Okay. No, so the best practice is you go with you first sort the data set. Initially, any kind of data set is not going to be sorted, so you have to sort it first. Like the smallest value at the top and the highest value at the end. Once you have the sorted data set, all you need to do is just track the approved or your dependent variable. And when dependent variable change, like in this particular case, dependent variable is changing at 650, right? So once as it's changing on 650, so the one value before that is going to be our point of interest. Okay. And in here, it's also 650. So that's why we are taking 620 and 650, both of them. And we will make a decision based on that. Like if it's less than 65 and if it's greater than 65, how much different categories we can separate. For example, in here, in this particular example, we are talking about the alcohol. So if you are taking this split, how better we can split the data set. Again, this will not be the only candidates. We will look in throughout the data. Like in that particular case, we are again changing this. We are seeing the change in the sign. Like here we have no, but it was before yes. So we are going to check this number as well. And so whenever the sign changes, we have to see a one number before that. Now these are all the candidates that can be a split, that can made split. So now based on that, what we are going to do is we are going to put these values again in the entropy formula, our Gini index formula. We will check the information gain for all of these points, and based on that, we will make a decision that what split should we take. Now this is all the theory behind a decision tree that goes on for making decisions, but in programming we don't need to go through any of this manually. Okay, all we need to care about the maximum depth that we need. Like in that case we specified 3, so that's how we are getting 3 here, 3 layers here, 1, 2, and 3. Also, the second thing that we should know that we calculated Gini index or information gain or entropy. So basically it tells us about the importance of the column. Like if we decided that alcohol should go to the first, or this independent variable should go to the first position, it means this is the most important variable, right? In this particular example, we have alcohol and it goes at the first position. After that, we see sulfates here, and if we look at it, here we have the sulfate. Okay, now let's go through the code as well. So we discussed the code till here. So what basically we go through here is we have a data set, we splitted it, we transformed it. We now have two kind of samples, one with actual quality numbers like 3, 4, 5, 6, 7, 8, other with three categories of high, medium, and low. Okay, and now we are going to deal with the numbers as a regression and the categories with classifier. So make sure that whenever you're working in this kind of environment, you should add the startify. Okay, just to make sure that you get equal number of qualities in different samples. Now, for this to understand, now suppose we have this small data set, right? And we're trying to split it into training and testing set. Okay. And so basically we train a model on some sample, for example, this sample, and the last row we used it for testing. Now, in our data set that we used for training, we have all the approved column as a yes. Okay. So the model will assume whatever we do, loan will always be approved. Okay. So now when you test on this line of code, so basically you give these instructions and ask it to predict, it will predict yes. Why? Because it doesn't even see any no value here, right? So that's why we implement Startify. So basically we yes and no have equal number of proportion in training and testing sets while creating the sets. Now we are going with the classifiers. That's regressor. That's why we're using decision tree regressor. Again, it's coming from sklearn. If we go to the top of the file, we will see that we imported sklearn tree as a decision tree classifier and decision tree regressor. Okay, I'm in VS Code. It might feel different to you, so that's why I'm going back to Google Colab. Here we are. So from sklearn tree, import decision tree classifier and regression tree. Okay. Again, this is for our model. This is for splitting our data set and getting different scores, matrices like accuracy, classification report, for mean square error. Now, whenever we are talking about, now this is standard truth. Like if we are talking about regression problem, we will always be working with mean square error, R square, mean absolute error. Okay, because we have a continuous number and we evaluate based on the continuous matrices. Whenever we're talking about the classification problem, we will always go with confusion matrix, recall, precision, accuracy, and all that stuff. One more thing I think that I should discuss, like we know how it works, right? How we deal with the classification problem with the regression with decision tree model. Okay. Now, if we are working with the problem where we are trying to predict or where we're using regressor, like decision tree regressor. Now, how does it works? Like till now, we only studied that it works with category, right? So in regressor, we use the same style of Gini index and entropy, but the main goal is shifted from having splitted categories like here in the century model, we are talking about that we need to split three categories, right? But when we are talking about regression or a problem with the continuous dependent variable, now we don't have any categories. We are just numbers like 3, 3.5, 4, 5, 5.5, or something like that. So end goal is not about any kind of numbers here, but the end goal is always about the least variance. Okay. Now variance basically represent the spread in the data set. If we have more spread, it basically means we don't have more control over the data. So that's why we try to minimize variance as much as possible. Now, if we take a look at the code, we just import classifier, we use it with the classifier, we take predictions, and based on that prediction, we created our confusion matrix, right? Same stuff, we create the confusion matrix right there, we get the importance of each column. Now, how we get the importance of each column? So basically, our model have a parameter that represent feature importance. Now here dt.classifier basically is our model that we trained. Like if we want to see it, here is the model dt.classifier, the decision tree classifier that we fit. Okay. It has a parameter that's represent feature importance. So in this particular case, we get a data frame. In data frame, we provide it with all the column like feature names. Feature basically means variables or column names in our data set. And importance is basically we are getting from our model and we are specifying that we need feature importance of each feature. We sort the values. So basically we get a clean graph like with the highest number, and then we defined our figure size. We defined that what kind of plot we need. Here we're using bar h, and based on that we're creating the plot. Again, simple Lex label title, we already discussed all that stuff. Now for plotting a tree, we have function plot tree. Here we have to provide our model. We have to provide that number of, we need to provide the depth of our tree, that how many layers we have in our tree. We need to provide the feature names, so it can specify the feature names in the blocks. We need to provide the classes names and all that. We can increase the font size. We can talk about the rounded. If we make it false, we get higher numbers and all that stuff. And field basically is representing the colors. Now, okay, so till now we discussed what decision tree model is, how does it works. It works on both kind of problem. How does it works in both kind of scenarios? And now there are so many loose ends, like how do we decide that what should be the maximum length? How do we know that either this should be the end of that, this should be a leaf node or not? Leaf node basically mean there should we end our decision tree or not. Okay, so now to answer all these questions, we have a term grid search. Now basically in every machine learning model we have some hyperparameters. Like hyperparameters basically helps us to find the best model, right? Now if we are talking about this particular case, now where does hyperparameter, I mean where does we see hyperparameter, right? This should be the first question whenever we're talking about. So basically all these terms basically are called hyperparameters. Like what should be the maximum depth? Now by modifying these parameters we end up with the best model, right? Like for example, if a model is giving best result in maximum depth of 3, we should go till 3. And if we go to 4 or 5, we might get worse result or bad results, right? Now in the case of decision tree model, we have 3 different hyperparameters. First one is the max depth, that we decide that how much number of levels our tree can grow, right? The second one is minimum sample split. Now, what is minimum sample split? Now, minimum sample split basically means minimum number of samples or minimum number of rows in our data set required in a node to attempt splitting. Okay. Now, if we are saying here that it should be 20, and if it's not 20, it will represent it as a leaf node. For example, now this is our decision tree, right? We made a split, we come to this. Now basically based on this condition, that if this condition is met, then rest of the data goes in this section, right? And this section has less than 20 rows. So basically it met our condition of minimum sample splits, right? So it will consider it as a leaf node. So basically the last node, it will not split it any further. So that's what minimum sample split is in our data set, in our model. Okay. The third thing that we have is minimum sample leaf. Now, minimum number of samples required to be at leaf node, right? This is kind of similar to minimum sample splits, but it ensures that leaf nodes have at least a certain number of training samples. Okay, we can modify that, we can modify that, we can modify that. Different terms can help us to find the best model. Like if you're getting accuracy something like this, so we just modify this and check if it's getting better or bad based on that. Okay, so that's basically what we call fine tuning a model, or finding the best model out of all the models, right? Now for this particular reasons, we need some kind of tool that helps us to find all these, right? And for this we are using, I'm not running the code, that's why I'm not disconnecting it, because it's already showing the outputs. We don't need to run it again right now. But if we take a look here, okay, so we have function in sklearn grid search cv. So grid search is basically a function that helps us to find the best parameters or best hyperparameters for any kind of models. Okay, now in this particular case, now how does it work? So basically we create a dictionary and we provide it with the dictionary that it will use to find the best model. Now here we are telling it that this is our dictionary that you can use. So you can either have a maximum depth of 3, 5, 7, 10, or none. Maximum minimum sample split should be 10, 20, 50. Minimum sample leaf should be 5, 10, 20. And it can go through use both of the methods, Gini, impurity, or entropy. So what it will do is it will check out all the combination and find the best model. Okay. We created this dictionary, we give it a name, parameters, grid classification, we provided it in our grid search CV. We also need to provide that we are talking about the decision tree model and cross validation of 5. Okay. Scoring is basically accuracy, so we need our model to talk about the accuracy. Based on that, it will just train the model again and again, and based on that it will give us the best parameter. So we define the grid search classification, and it contains a parameter like best parameter. So once we run that, it will show us that we should go with Gini impurity with the maximum depth of 5, with the minimum sample leaf of 5, and minimum sample split of 10. And it will give us the best cross validation score of 0.6368. Now, the one question that one should be asking right now is what is CV or what is cross validation? Right now, let's talk about what we are talking till now. Now, this is our data set, and till now, we are talking about 80% of the data goes in training set and 20% of the data goes in testing set, right? But when we are talking about the problem with this approach is sometimes we get so much better data in training set, but testing set don't have such a data, or we get bad data in training. Due to that, we cannot go to the true potential of our model, right? So to avoid that, what we do is cross validation. Now in cross validation, we instead of creating 2 different sets, we create 4 different sets or 5 different sets, right? And in 4 or 5 different sets, we go through all of the iterations. Like at first attempt, we choose first one as a testing. In second attempt, we choose second sample as a testing. So it shuffles all the data sets to get the best results. Okay. So that's why when we are trying to grid search over all parameters, we are going with the best parameter. That's why we are using cross validation. So it should not be biased due to our data splitting style. From here, now we get the parameters in the grid search. We can do it for regression as well, and based on that, we can also again train the model and can get the classifications or accuracy. Right now, if you're talking about the regression problem, we will go with mean absolute error and root mean square error or something like that. And if it's classification, we will go with classification terms like accuracy, recall, and all that. Now, the advantage of using decision tree is it's more interpretable. We know what column or what independent variable is most important. Based on that, there are no any kind of assumption. Feature selection, now it automatically performs the feature selection, so we know which one is important and which should we consider more if we are trying to get some kind of results, right? It also captures non-linear regression, linear relationships. When we're talking about the linear regression, we are talking about some kind of linear relationship between x and y or dependent and independent variables, but here there is no such a condition. Okay, now it can handle the missing values. Missing values is not a problem here. So if you are not imputing the missing values, it's totally fine. You don't need to even impute or worry about the missing values. Now the limitation is overfitting, right? For example, if your decision tree is with the 5 layers, now if you get a decision tree with the 2 layers and it's working perfectly fine, but to increase the accuracy for 0.1 or 0.4% or 0.3%, you increase your model from 2-layer decision tree to 10-layer decision tree. So basically, you're overfitting the model, and due to that overfitting, it might perform better on training set, but on the testing set, it will be worse. Okay. And again, it's also going to be computationally heavy because we are not using any kind of mathematical formulas here, but I mean, if we are using mathematical formulas, but it's kind of manual style, and that's why it's computationally heavy. And also, it's kind of a kind of unstable model. Like if we are generating results based on entropy and Gini index, but if we're trying to change something in our data set, our whole tree will look something different, and the whole tree might not be reliable anymore. Okay, now if we have more than two or more than three, 10, 15 different problems, different categories, so it might be biased towards some features, and that's why this is kind of a limitation in it. Now, here is a different a comparison between the regression approach and the classification approach, because we are working on the same data set. So you can just take a look at this, very simple and basic stuff. So that's it for today. In the next session, we will discuss about the random forest, that is basically continuation of decision tree model. So it's going to be interesting.